In this last section, we're going to look at how to build a line chart, and this brings a few interesting challenges, and we're going to take a look at how we can solve some of them using Python. And it opens a lot of doors, and that's going to be my last section. It's the most complex one. We're going to go into scripting quite a bit, and we're going to explore a few things, but feel free to watch again and again if you and also remember that I will put all the script that I've written during the blog. I'll put them at the bottom, and also I'll package the project, so if you want to look at the files and things like that. So it's going to be possible for you to try a few things. And let's get started right away. We're going to build our graphics, the graphic of the line chart first, and I'll use a few techniques that are interesting. I've tried a few things, and I found that those are the ones that work best if you want to do a revealing graphics for a line graph. So I'll go into front view to start with, and I'll create a rectangle. That's going to be the shape of my line graph, and I want that to be 3D, so I'm going to just give it the original shape. Once we've got the original shape, I'm going to convert that one to an editable spline. And if you grab the top spline here, there's a function. If you go at the bottom somewhere, it's called divide. Let me find, I think it's quite low. So here is divide. So we've got two vertices, one here and one there, and we'd like to have, and we need to come up with a convention, because when you do a line graph, what you're trying to do is you're trying to show values over time, like a stock market, a stock evolution over a day, or the market, like NASDAQ evolution over a day. So you need to define how many points you are going to put on that graph. So it depends on how many readings you have per day and things like that. So to keep it simple, I'm going to make it with 10 readings, and we're going to create our own file format for that. We're going to go in Excel, and we're going to create a CSV file, which is quite a common format for array of values saved in a file. But you'll see with Python, you can go and query pretty much anything you want. And that's the beauty of Python, is that you have a bunch of libraries that allows you to query different sources, different data sources. And in this case here today, we're going to do a CSV file. So we need to define how many values we're going to put in that file, or how many we're going to get from that database, or from that data file. So in this case, we're going to make it 10, so it's going to be easy. So I'm going to divide it by, so if I wanted to, we already have 2, so I'm going to divide it by 8. So I'm going to say divide, and now I should have 10 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're good. We have 10 vertices, and that's going to be our 10 readings. So that's kind of the base for our graph. Now that we have our 2D geometry with vertices at the top, I'll go back to my perspective view, and I'm going to start to extrude this and give it a 3D aspect. So right now we have the vertices, and I don't want to go inside of the vertices, inside of the editable spline, trying to find the vertex ID and all of that when I'm going to do the scripting. So there's a nice way to do this in a very elegant way, and it's using the Spline Ik modifier. So if I go here and I use the Spline Ik, which is here, Spline Ik control, it allows you to create control objects for all of the vertices on this geometry. And you see that here you've got the ability to link it to the hierarchy, link it to the root. But in our case, all we want is we want to have helpers that will allow us to move those vertices without going into the actual geometry. So I'm going to say create helpers, and you see that every vertex receives a helper. And if I grab this helper here and I move it up and down, you see that it changes the shape of the geometry. So what I'll do here is I'll just select a few of those, and I will change the size here. And you can see here, I'm going to take a look at I'm going to go and move here just to take a look at the position in Z. So it's 57. So let's make it 60, for example. So 60 is a round number. So that's around 60. And this here is going to be at the top here, maybe 100. So 60, 100. It's going to give us an idea of where we want our values to be. And actually, this one could be a bit lower, something like maybe 30. So between 30 and 100, our graph is going to look good. So we're going to put values in our CSV file that fit within that range. Of course, if we want to change values or make values bigger or smaller, we can also easily just do some normalization and make it fit into this by using a script or simple math. But I'm not going to do that today. I'm just going to make it as simple as possible. I can see here that all of the top there is kind of rounded. So if I go back to my editable spline, I'm going to go select all the vertices, Control H, select all the vertices, and I'm going to right click and say I want all of those to be corner vertices, and then we can go back here and go to the spline control, and you see that they're all corners. If we want to have a sharp line here. So you see that we have all of these, and we will want to access those point helpers. I'm going to maximize the window here, but we will want to access those point helpers to the scripting, so it's always good to rename those. I'm going to select them in the order from left to right. So here we go, like this. And the reason why I'm selecting this in this order is I'm going to use the rename tool. If I go in tool and rename object, it's going to go by my selection order. So my base name, I will call it, I don't know, something like line. And let me see in my notes how I want to name this. So line point underscore, and I'm going to give it a name, number. The base number will be 1, and then it's going to step by 1. So I'm going to say rename, and we should have all of these name line point underscore 02, and that should be 3, 4, and that's good. So they're all named correctly. The 2 at the bottom here will be constant, so I will never have to access them by script, so I don't need to rename them. It's fine. So what I can do as well is that I can just go here and say select similar. Select similar. It's going to select all of the helpers. I don't really need to see them anymore because I'm going to update them through scripting, and I don't really need to select them, and I don't want the user to select them either. So what I can do is I can go into the properties for these objects. I can say freeze them, don't show frozen in gray, and I also want to hide them. So now all of them are frozen, they're hidden, so the user, even if the user does unhide all, they will not be able to select those point helpers. But my graphic is still good to go. So now we can go and say we want to define the look of this. So what I'll do is I'll extrude it first. So we're going to just put an extrude modifier here, and we're going to extrude it, towards the back. Also, if you want to, let's say we want to have some chamfer at the top here. So what we can do is I'm going to put a poly select. So poly select here. I'm going to grab all of the edges that are at the top, and as they are selected, I'm going to put a chamfer modifier and just make it something like that, so it looks a bit better. Once we're done with this, I'm going to put another poly select to cancel my poly selection. So it's at the bottom here, poly select. Here we go. So we have our poly select to select nothing, and I would like my graphic to reveal from left to right. So what I'll do is I'll put a slice modifier, and the slice modifier brings this slice plane, and this slice plane is fully animatable. So I'm going to rotate it 90 degrees in that direction. So make it 90 degrees like so. And the slice plane, I can say split mesh, remove the top, remove the bottom. So if I just remove the top, you see that we have the remove of the top there, and I can animate this easily. So I'm not going to animate it for now. I just want to solve a little problem. You see that there's a hole here when you do a slice. So what I can do is I can go at the top here and put a cap hole modifier, and now the hole is capped. But I can still go back to the plane here, and I can move it left to right, and you see that we can animate that. So if I just go to the left here and I say auto key, and I want to reveal this, I don't know, maybe over 50 frames. So I'm going to go and up to the end of the graphic, somewhere like here, and now we have our animation of this being revealed over time. So we got our animation. It looks great. It's on 50 frames. If it's too slow, I can just grab the slice here and make it a bit faster. Maybe 30 frames will be a bit better, so it looks faster. That's better. Now we can, in order to save this and package this, I'm going to create a camera, and I'm going to make it a free camera, and I'm going to go and show the save frame. Let's take a look at how far we want to be from the when we are at the graphic here. So I'm going to dolly in a little bit, something like that. That's going to be the end position. So since the camera is selected, I'm going to set a key here, and I'm going to just dolly out maybe from something like that, and maybe orbit around something like this. Snap by angle. So let's say that we kind of, oops, and I didn't set a key. So let's go back. So that's going to be my beginning, somewhere like this. We are going to orbit around, something like that, and I'm going to set a key and maybe dolly out a little bit. So set a key, and we're good to go. Play, and we got our graphic animation. It's not the most beautiful graphic animation, but you get the idea that we've animated this and we're in camera when we save. So if I go and I save this now, I'm going to put it and I'm going to call that a line, save that. And now we have our animation, our base scene to start that we can start to automate and create a template out of it.